Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest's Sciences and Mathematics TV channel. In this specific discussion, we're going to look at the characteristics of this specific part of the subatomic particles, which we refer to as a neutron. And we're going to see that in our various discussion for the radioactive decay processes, this specific particle is going to be heavily involved, especially in trying to come up with various radioactive isotopes and the final stable product, which you're going to see, of course, being given at the radioactive decay series. And this is going to affect both the artificial and the natural radioactive process that we've already mentioned in one of our videos. And for today, I'm going to look at the various properties of this specific subatomic particle that we refer to as a neutron, and some of the sources from which these specific neutrons can be found. And lastly, we're going to look at some of its application or the uses of this specific neutron. Now, insofar as the properties are concerned, I mentioned in one of our videos a comparison of these three subatomic particles that we have discussed. And in some areas, of course, we're going to see that there's going to be an advancement or additional information of some of the aspects that we're going to see insofar as energy is concerned, and the radioactive decay processes, which are going to create a contrast in this specific case. As we had said, of course, from the advancement of the atomic structure, we had said that basically the concept of an atom stems from the description of Democritus, which he had given the concept of atomos referring to indivisibility. Now, with advancement in technology, we're going to see that there was a description of the subatomic particles, which implied that basically an atom can be able to be divided further into subatomic particles. And in this case, of course, we're going to see that there are some various aspects of experimental data which are going to give an evidence on some of these characteristics. But insofar as charge is concerned, we had said that these are going to be, basically this mass, we're going to see that there's a unique way in which we can be able to describe protons and neutrons ratio of their masses and the electron. And we concluded that the mass of this specific atom is basically centered in the nucleus. So therefore, we're not going to concentrate much on the masses of this insofar as radioactivity is concerned, since it's the one that is going to have a higher implication as compared to the electrons. So insofar as charge is concerned, we say that these are positively charged, these are neutral, and then these are negatively charged. And we're going to display them as such in this specific discussion as we go ahead. Now, for the concept of the neutron, we're going to look at the various properties which are going to be displayed by this specific subatomic particle. Now that it's going to be heavily involved in this radioactive decay process. Now, one of the characteristics is that the neutron basically consists of what we call the quarks. So we are going to talk about the concept of composition. So we're going to have what we call two down quarks, and then we're going to have one up. No, I'm not going to talk much about this specific concept, but we're going to have an elaboration of it later in our discussion. And we have what we call the concept of rest mass. So for a neutron, we can be able to describe this rest mass as 0.866, and that is 49 atomic mass units. So this is one of the characteristics of a neutron. And then we're going to see that the equivalent energy, so this is equivalent energy in terms of electron volts. This as well as a specific value of 939. This is 56 electron volts given as such. Another of its characteristics is of a charge, which we have mentioned. So electric charge, which we have mentioned that it is basically equivalent to 0, and a half-life of course, this is outside the nucleus. This is going to be a half-life of 10.4 minutes, and then we can be able to see that it's going to have a specific or a characteristic decay scheme, which we are going to mention later in our discussion. Now, apart from these properties, there are different sources whereby we can be able to achieve this neutron from. And as we said, one of the ways in which we can be able to initiate the process of radioactivity, artificial radioactivity, is through the bombardment of specific, of course, isotopes with these neutrons, and in order to initiate that specific process. So, therefore, it's pertinent for us to understand various sources whereby we can attain these neutrons. Now, the first one is the alpha sources that we're going to discuss how that one is achieved. So the second one, the neutrons can be achieved from the gamma sources. Now that we have talked about the concept of gamma and alpha, and then we can be able to achieve this one from the process of spontaneous fission, sources, and then we can also achieve this from fission reactors. And then lastly, we're going to achieve this one from what we call accelerators, particle accelerators, which we're going to look at later. So in this specific case, these are different sources whereby we can be able to attain this neutron from. And of course, it's going to be elaborate for us whenever we're going to have nuclear equations constantly the same. So some of the applications of this specific neutron, of course, we're going to see that it's going to be applied in what we call the reactors. I've mentioned the concept of reactors, and then it's going to be applied. So this is for reactor startup, and then it's going to be applied in what we refer to as activation analysis. And then we can mention about the density. Of course, this is the density and the moisture gases. So this is going to be moisture gauges. And lastly, least but not last, we can talk about the research, especially in medicine. Among others. So these are some of the applications of this specific concept of the neutron, which we're going to discuss and find out later in our general discussion or specific discussion on the various aspects of this radioactive decay. So apart from this ones, of course, it's going to complement on the alpha, beta, gamma decay processes that we have discussed in some of our videos. And this, of course, is going to be mentioned particularly in some of the areas that we're going to come across, especially in the medical field, as we have seen for the electron capture for the positron emission tomography, which we had mentioned that is going to be used in the medical field to, of course, do the procedure of scanning. This is also going to find specific applications in some of the areas that we have mentioned. Now, our last discussion is going to entail a sum up of what we have already discussed for these decay processes, and it's going to be a summary form, and perhaps it will involve the energy scheme diagrams for these various processes that we have mentioned. So catch us in our next video as we're going to look on the same and do a sum up of what we have discussed basically on the concept of radioactive decay processes. So that is it for now, guys. Bye. God bless you.